Alright, I'm going to try to make this video quick because my space on the computer is limited, but let's jump right into it. So first we're going to open up XFLR5, so let me go and do that now. Alright, so first we're going to want to start out by starting XFoil Direct Analysis. Going to File, Opening, and you're going to want to open your Clark Y data file. And now remember with the data file that the way you want it arranged is from the top edge, trailing edge to the leading edge at the top, and from the bottom leading edge to the bottom trailing edge in that order, or the program won't be able to pick it up correctly. We can see when I open that up. Oops, no. So let's go File, open that data file. Then from there, go to Analysis. And we need to define an analysis. Here we're just going to use a type 1 analysis type. We want to change the Reynolds number to 1 million. And we're not really going to mess with any of the other transition settings or Mach number. All right, and then we're going to see that load up here. And we can see the polar properties displayed below. We do want to run a sequence. As given in this project, it was from -5 degrees to 20 degrees with an iteration of 1. Then we just click Analyze here. All right, and then it goes pretty quick. Here we have the coefficient of lift versus coefficient of drag, uh, and a few other of the charts displayed here. And what we could do from here is right click, go to current graph. Hold on. Oh, and then export graph. Okay. And then you'll export the graph to the point where we can open it in Excel. And let me just open up mine. So then you could open up in Excel. So this one's for, I have them all uploaded here and condensed together. It just makes it easier to interpret the data and calculate different things that you need from it. So let's go back here. Next, what we want to do after this step is we want to determine properties of different wings with different aspect ratios. So from here, we'll go to Analysis, Batch Analysis. We're going to do a range from 100,000 to 500,000 Reynolds number with increments of 10,000. Type 1 analysis. We're just using the current foil only. That's going to be the Clark Y one. But if you were using multiple, we could go foil list and type in multiple, and it will calculate multiple at one time. Again, our analysis range, we're doing from -5 degrees to 20 degrees with increments of 1. The max iterations I'm going to leave at 100, but you could up that to make it more accurate. I just don't want to crash my computer at this moment. And we'll see it run through those iterations right now. All right, so now we could close this. It has, most of the charts have converged for all the differentiating Reynolds numbers, which we could see in these corresponding graphs. From here, what we want to do is analyze wings. So what I want to do is open File, Wing and Plane Design. Go to Plane and define a new plane. This one, just as an example, I'll use an aspect ratio of 4. We're going to turn off elevators and fins. We don't need biplanes either, or the biplane to display either. We could define the main wing. And again, we're looking for aspect ratio of 4 with the taper ratio of 1. So since the taper ratio is 1, the chord is just going to be the same at both ends. We're going to have no offset. And then we just want to switch the foil to our Clark Y foil. And now we can see our aspect ratio is of 4, taper ratio of 1. And we could go ahead and save that. And then go save again. And then we could click up here and switch to this, and we'll be able to see the foil we've just created. And it gives a bunch of stats down here if you're interested. From here, we need to analyze or go to analysis and define an analysis that we could run on this airfoil. We want the free stream speed to be 10 meters per second with the type 1 or fixed speed. Go to analysis, we're going to use LLT for the wing only and hit save. From here, set the parameters, so the same ones as we were using before. And then we're just going to click analyze. Then if we could rotate here, we could see, which one was it? I guess just this one. You can kind of see the different forces coming off. We could click on induced drag if we want, the viscous drag, downwash, and so on, and it will display it here. And we could even go to animate and have it animate as it's changing the angle of attack, and how different things such as downwash and viscous drag take into or are affected by such. But what we want to look for here is we want to go to the polar view of these graphs, and then it will display all of the graphs here, as we did with the first one, from which we could export to Excel and save the data.